I'm going to get started. Everyone, please feel free if you're comfortable to put your video on. But as Butle said, just keep yourself muted. If you have a question, just raise your hand and we'll try to attend to it as fast as possible. Alternatively, just send questions in the chat and one of the team will respond to it. And yeah, so it's great to have you all here. Thank you for coming to the basic to intermediate R-HTA. And today we're basically going to we're going to try to focus mainly on the very basics of R, getting to grips with understanding the language. So for the first time, we're really trying to delve deep into understanding how the R language works, how the logic of the language, and we're going to spend quite a bit of time on that today. And then you will be given an introduction on visualization in R, which is a great strength of the R language as well, and why it's used a lot for data science, etc. And then finally, you'll be taken through a simple decision tree for modeling and at the end of the day. So I'm going to ask team members, Satoshi and Islam, to introduce themselves, a bit of background on their speciality, and their presentations for today. Islam, can I ask you to go first? By the way, I'm yes. Joshua. Sorry, Islam. To give myself an introduction, I'm Joshua, and I'm a co-chair of R-HTA and LMICs. We've recently expanded our scientific committee, and we have Hannibal, Islam, and Satoshi here today, and they are a part of the bigger scientific committee, bringing a whole set of new skills, and we can also try broaden out, not just focusing on health economic modeling, but epidemiology, data science, etc. And yeah, I'm looking forward to that. So I'm a consultant in the UK. I am from South Africa. Yeah, I'm going to pass over to Islam to introduce herself.
Thank you, Joshua. So for my side, I'm Islam Mahrzi. I'm a member of the scientific committee of the R-HTA in LMICs group. And also I am a senior data science engineer. Basically, I'm a business intelligence and software engineer, but later on I specialized in data science, and mostly I have extensive experience using R language. So I have 7 years of experience in French company, and now I am working independently as an independent consulting. Yes, that's it. And now the stage is yours, Satoshi, I think.
Hi, thank you, Islam. My name is Satoshi Koiso. I'm originally from Japan, but I'm now based in Boston. I'm a member of the scientific committee of R-HTA in LMICs. And for my daily job, I'm working as a research specialist at Massachusetts General Hospital. And I'm making simulation modeling with R and do cost effectiveness analysis. And I'm very happy to have a meeting with you all guys. Yeah, thank you very much.
Great. Hannibal, I know Hannibal is also a part of our scientific committee. He's not presenting today, but Hannibal, do you maybe want to introduce yourself as well?
Yeah, sure. Thanks, Josh. Hi, everyone. My name is Hannibal Msarura. I am also, like what Josh said, a member of the scientific committee. Day job, I teach a number of courses, including biostats, and we do that using R. And I'm glad to be here to at least help with the HTA program. Thank you.
Great. So before we get started on any materials, I'm just going to quickly take you through today's agenda as a refresher. Let me just share my screen. Okay. Can anyone confirm that they're seeing the agenda for today?
Yes.
Okay, perfect. Thank you. So today, on the next session after I present this, I'm going to give you a very brief overview of what is health technology assessment. So this is going to go through a bit of history to ground you guys, to kind of give an idea of how it developed, what it entails, and how HTA is a lot more specific, but also multi-team, it's a multi-team, multidisciplinary process compared to just being specific to health economics. So HTA is quite a broad process, and that's why it's quite complex. And I'll end off with kind of bringing that into why we advocate for HTA. And then after that, Islam is going to give an overview of what is the R language. So using her very specialist data science skills, she's going to give you a breakdown of what the programming language is, where the main resources for R or packages for R are stored. She's going to give you an idea of how to interact with RStudio, so how you use it, what are your main panels, and how to kind of use it to its best capability. And then finally, she'll also give you an idea of the key concepts in R, so syntax, data structures, kind of giving you an idea of when working with R, how do you understand the language and how to appropriately manipulate objects, and then also a breakdown of how functions are used in R. Then she will take you over some practical examples, and then give you just a little taste of web scraping, which can be applied further to ideas of evidence synthesis, etc. But we're just going to keep it simple for now, giving you a simple idea of how easy it is to automate processes in R. And then we will have a brief group work session. So this is where you guys will be put into breakout rooms, and you'll be given a few exercises to complete with the materials that Islam presents. Okay. Then we're going to take a short break. And afterwards, Satoshi is going to give us an intro to visualizing data using R, giving us a brief example of how R compares to Excel and Stata, and then an overview of the types of plots you can do in R. And then we'll actually go through a whole lot of code on how to generate these plots. And some of these plots, for example, a tornado plot relates directly to what you would do in a HTA submission for a health economic model. Oh, why is it being weird? There we go.
So Josh, there's messages that your screen is a bit blurry. Yeah, I mean, I also saw it as well. It was a bit blurry. Just maybe scroll up and down for a bit. Let me see. Yeah, it's okay if now. I don't know. I mean, your video is not also showing clearly. Do you maybe want to switch off your video for now? Sorry.
Yeah.
And let's see if that maybe improves things. Okay.
Any improvement?
No, not from my end.
Damn.
Unfortunately.
It's bad.
Okay. Yeah, no, it's really fuzzy. It's
Okay.
really
So
fuzzy.
let's see.
Okay, I might have to ask Islam or Satoshi to present
On the right side of the web data collection sections.
the HTA slides, but I'll send the link. Okay, so finally, after we have another breakout session with Satoshi, kind of giving you some practical examples on visualization. We then have another break for 15 minutes. And after that, we are in the final period of this workshop, where Butle will take you through building decision trees using R, and then you'll have a bit of a group work exercise for 15 minutes. And afterwards, we'll just sum up today's learnings and open it up for some brief discussion. Okay. Islam or Hannibal or Satoshi, can you guys hold on? Can one of you maybe download the PowerPoint presentation in this link and then share your screen just so I can present it and at least people can see? Is that possible?
Yeah, I'm trying.
Let's give it a go.
Okay, brilliant.
Okay, I'm ready. Or is anyone like assign me the access to share?
Yeah, I think, can you just share your screen?
Oh, it's disabled for now. Probably because like I switched my account.
Okay, yeah. Hannibal, are you able to share?
Yeah, let me give it a go. I think I should be able to.
Yeah.
Oh, yes, I am. Let me just find the screen now.
And then Buffle, could you maybe just reassign Satoshi?
Okay, yeah.
Is that right? Yeah.
Okay. There you go. Can you guys see the screen? I'm sharing now.
Yep.
Okay, so I'm just going to put it in presentation mode, and yeah. So yeah, just let me know when to move.
Okay. So slide 1. So this is going to just be a brief introduction to what is health technology assessment, what entails, some history, etc. And yeah, if you could move to the second slide, Hannibal. Okay. So the World Health Organization, that they've always defined HTA, and that's always been the go-to for our understanding of HTA. But generally speaking, health technology assessment incorporates stuff that's been going on for a long time in pharmaceutical research, etc., and product development. So obviously this includes safety, effectiveness, and costs. And these are things that were generally studied and applied as far back as the 60s and 70s. And basically, because there was an increasing technology across all societies within pharmaceutical products, there became a need to basically systematize technology assessment into a formal process. And so that we can evaluate, as we know in health technology assessment, the safety and benefits of a health technology. So surprisingly, this fact's always surprised me, is that the first body to try and look at the
Yes, I found it, but thanks a lot. Yes.
The first body to kind of try look at the incremental costs and benefits of health technology was actually established in the US in the 1970s, and it was called the Office of Technology Assessment. And then in 1976, it was actually established. They established their first health program, and they were looking at any social, ethical, or legal / political concerns of certain health technologies. And then after that, in the 80s, the actual first HTA-specific bodies or agency supporting government decisions were established in Europe and Canada. And then the International Association of Health Technology Assessments, which is basically a group of HTA agencies, was established in 1993 with 11 member agencies. And now it's 52 and 33 countries. So 52 and 33 countries, that's also because, so for example, in some countries, there might not just be one health technology assessment body or agency. So for example, in the UK, you have NICE, which is the National Institute for Care and Excellence. for England. They do decisions broadly, can do broad decisions for Wales and Scotland, but Scotland, more so than Wales, also has their own agency called the Scottish Medicines Consortium. And then Wales has AWMSG. I always forget what that acronym stands for, but they do have their own independent body, but they are far more smaller and do far less formal assessments than NICE or SMC. And then also in Canada, you have CADITH, and then you also have a NES. A NES is for the French-speaking regions of Canada. So the original definition by the World Health Organization, they've basically formulated as a systematic evaluation of the properties or effects and health impacts of health technologies and interventions. And this covered basically the direct and intended consequences of a technology, as well as the indirect unintended consequences. And the indirect things are stuff like social benefits, so people being able to return to work, or stuff like that. And then the direct consequences are stuff that we can directly know about. So what is the treatment effect? How much does it cost? What does it displace in the health system, etc.
Isso é o que você contratou? Você falou pro Dita?
Hi, so hi guys. Sorry, just a reminder to just mute your mics for now.
Your
Thank
microphones.
you. Yeah. And then if you have a question, just raise your hand, and one of my team members will let me know. And then, so broadly speaking, HTA is mostly about how to best allocate funds within a health system. So because there are limited budgets that are allocated to the health system, the broad idea is how best do we use that budget to gain the most health. And then HTA, broadly, according to the WHO, is a broad interdisciplinary, it requires a broad interdisciplinary team or groups to have explicit analytical frameworks where they draw on clinical, epidemiological, health economic, or information, or other information and methodologies. So, for example, statistical methodologies like indirect treatment comparisons, evidence synthesis, or more specifically, meta-analysis or network meta-analysis. And health technology can incorporate many different types of technology. So it can be a direct intervention, like a type of surgery or gene therapy. And then it can also be something as simple as a new application for certain patients for, health behaviors, etc., where they, can just be an application that they have on their phone or anything like that. And they can also be devices. So it can also be actual surgery devices or learning devices or a new hearing aid, etc. And the main purpose at the end of the day for a government or a HTA agency which represents the interests of the public is that they use the outcomes and the evidence to negotiate a fair price. So unlike the USA, a lot of other countries will assess a new technology, and based on the incremental cost effectiveness of the technology, they will then negotiate a cost effectiveness price based on that. So then slide 4. So recently, a new definition of HTA has been proposed. It's far more specific and it's far more less verbose and to the point. So according to this new definition, HTA is a multidisciplinary process that uses explicit methods to determine the value of a health technology at different points in its life cycle. The purpose is to inform decision-making in order to promote an equitable, efficient, and high-quality health system. So again, a health technology is an intervention developed to prevent, diagnose, or treat medical conditions, provide rehabilitation, etc. And then the process of HTA is supposed to be a formal, systematic, and transparent process which uses state-of-the-art technical methods and to consider the best available evidence to make a decision. And then the dimensions of value for health technology may be assessed by examining the intended and unintended consequences of using a health technology. So note that that is a little bit different to the WHO wording, especially, and that's because in different HTA processes, the agency will not consider societal benefits. So, for example, in England with NICE, the standard technology assessment routing, where most medical products are assessed, they will never really consider societal benefits as a scenario analysis. Whereas when you go through highly specialized technology assessments in NICE, they will always consider wider societal benefits as a scenario and the value of that. And that is largely down to the HTA agency's own position on whether they want to incorporate such things into their technology assessment. But yeah, I think that's quite a very slight but important difference. But the dimensions often include in HTA clinical effectiveness, safety costs, and economic implications. And then along the ethical and social and cultural dimensions, this is where we see a lot more appreciation or acknowledgement of any health inequalities and any discrimination within the health system. And often HTA bodies will consider that in sometimes a systematic quantitative way, but often this process is done in a more qualitative way where they engage with stakeholders, patients, and clinical experts through a discussion around a roundtable during the technology assessment. So an important point here is note 4, which HTA, this new definition suggests that HTA can be applied at different points in the life cycle of a health technology assessment. So it can be pre-market, during market approval, and post-market, and through to the disinvestment of a health technology. And I think this is something that's emerging more and more in health technology assessment bodies or agencies, where they're realizing that at different points of a health technology, there might be at different points of value. So, for example, if it's a very novel drug, it's pre-market, it's groundbreaking, they might assess it during market approval. So, for example, they might be having safety approvals in parallel with the health technology assessments, and the safety approval might happen just before the HTA happens. And at that stage, it might be a very novel new drug, and so it might be highly valuable. But in 2 years, there might be several other similar technologies that have come into the market. And at that stage, I think health technology assessment agencies are wanting to have more flexibility in their negotiation because the market's changed and because the value of the product's changed. Its value, inherent value, is not reflective of its original price that the negotiation between pharmaceutical or health technology producers had and the HTA body. And I think that's something that's going to happen more and more. And to note, because there might be these living HTAs where these technologies are reassessed at specific time points, then I think R is much better for that. It's much better at keeping track or doing what's the right word, but basically continually updating the methods and the model. In Excel, you can suffer from so many corruptions of the file, things get lost, version control is far harder to keep track of. And with R, it's much easier to keep track of unintended mistakes in the code or something like that. And there's a lot more to that. So a lot of people have developed ideas of having what's called an API. So you basically build the model, you have a whole lot of inputs, and then automate the system so that the pharmaceutical can send over new data to the Health Technology Assessment Agency, and it can update the model and they can review it. And basically that's being proposed as what's like a living model as well. So overall, the purpose of the HTA definition is to understand its purpose especially in low and middle income countries. And the ultimate goal within a lot of these countries is for universal healthcare. So nationalized healthcare, setting up specific care packages, etc. And HTA is an incredibly important part of making that sustainable. So having a sustainable benefits package within your healthcare system. And the purpose of HTA is that when you initially build your UHC within a country, you establish priorities, priority treatments, which go through formal HTA, or a lot of these bodies will also look at other HTA agencies, look at the cost effectiveness, and make a decision based on that. And then the most important part is the maintenance, or as I said, the sustainability of the universal healthcare system. And this is where HTA is fundamental. And without it, health systems trying to aim for UHC by reducing out-of-pocket costs, etc., it would not be possible. Health technology assessment doesn't always get it right, but it definitely makes it far more sustainable and helps us, or helps decision makers in health systems make more appropriate decisions and more reliable decisions. So the general process in HTA within a health system is so this is slide 6, by the way, and HTA in the health system. So initially we have our technology developments, whether it's small bio startups or it's a big pharmaceutical, and they will develop their technology and then seek regulatory approval. So for example, if they meet safety standards, ensuring that it's clinically effective without severe side effects, etc. And once that's done, the product will go through HTA. And this is where the pharmaceutical has to justify the costs of their treatment, given the expected benefits of the treatment. And once that's been established, the HTA body makes a decision whether they recommend it or not. And if they recommend it, it's used in the healthcare system. And if it's not, then often it's not actually available in the healthcare system. So for example, in England, the decisions by NICE are binding, which means that if NICE do not recommend a product, GPs, general practitioners, or surgeons, etc., they cannot use that product in the health system. And they have to follow NICE guidance on the available product and treatment pathways. So lastly, steps used in HTA. So this is more about, as an analyst, what are you going to do? What are the steps taken when you're engaging with an HTA body? But the first step is defining the decision problem. So understanding what is the decision you're trying to tackle, what does it entail. So this often follows a PICO framework, or population, intervention, comparator, and outcomes. That will often provide the groundwork of the type of model that you want to do, and how you want to go about presenting your evidence. So in between analysis, defining the decision problem and analysis, this part will often entail also conceptualization of your model. What are the elements that you're going to incorporate, the outcomes, etc. And finally, you develop your analysis and present it through appraisal at the HTA body. And this appraisal process can take, depending on the HTA agency, can take often up to about 4 or 5 steps before you get to decision making. And at decision making, as I said, the product is recommended or not recommended, and based on that decision is guided, then the guidance for implementation is done. So implementation can also entail confidential negotiation that's happened between the producer or the pharmaceutical company, for example, and the HTA body. and this can have several negotiation aspects. So, for example, the pharmaceutical company might pay for at-home care. So they'll deliver the product to the patient at the home, and they will cover the costs of that in order to achieve a certain price. And then the HTA body might have a more flexibility in their pricing because of that. There's also risk negotiations. So if the HTA body feels that there's a certain amount of risk with the product and uncertainty, then the pharmaceutical might say, well, we really believe that our new product cures X disease, and if it doesn't, we'll pay for each patient that wasn't successfully cured, for example. And that can happen, although it's very rare, but it has happened in the past. So final slide 8. So again, just going through what I spoke about, and just gives you a bit more detail on what I've just gone through. So I'm not going to go through that again, but yeah, I think I'm going to open up to questions now before we move on to the next topic. Any questions? Okay. Thanks, Hannibal. I think you can stop sharing now. Appreciate it. Okay. Okay, we're about 7 minutes early, but I think I'm going to push ahead. I think that's good for Islam. She can have a bit more time for her presentations.
Hi.
Hi, yes.
Yeah, so since we have a bit more time, I just wanted you to talk more about the aspect of the, I think, social value judgment. So in the decision making, who are the people involved in this judgment?
It depends on the country, but often, so in South Africa, they have the medical board currently, the National Medical Board, I think. But for example, in England, the people that make those decisions are multiple stakeholders, some from governments, but mostly they are actually people that are hired, for example, by NICE. So NICE in England actually have their own NICE committees. So they break it down by like committee A, B, etc. And then those people often work for NICE and be a NICE committee member. The people on those boards have I think 3 to 5 year tenure. So they basically only stay around for 3 to 5 years, and they are a group of experts from health economics to experts in specific disease areas, researchers, and then there's often people, 1 or 2 people from NHS England, financial decision makers, etc. But this all depends on the country and who they consider the relevant decision makers, appropriate decision makers, I should say.
Are the patient advocacy groups, or are they ever included in this decision making?
Always included, but they don't have a final say, but they are always invited to comments and basically give their perspective. And this can also, often they're invited independently by the HTA agency, and then the manufacturer also has opportunity to bring their own patient stakeholders in. And yeah, so this can take multiple forms. The patients might advocate for it. The patients might say, actually, we don't want this technology. We want another technology that's coming out in 2 months or something like that. But they are often, I know for England, they're not often they aren't on the final decision-making board. They're brought in to give their perspective.
Thank you.
Satoshi?
Yes, I am here. I can start if that's okay.
Yeah, I think let's get started. I do apologize to everyone for my timekeeping, but handing over to you, Satoshi.
Okay, thank you very much. I'm Satoshi again. Hello everyone, but let me turn off my camera for better internet connection for everyone. And then just for reminding like where the all other scripts and also the presentation is, like you can go to the GitHub and then you can download all the files, like just clicking this arrow and then download the zip. And then the materials of my session is under R, and then under data visualization. Like if you already download, like you can go like this one, and then share some presentation. It's not finalized version that I will present for now, but just most of the up to date. And then one R script and 3 related data. Okay, let me go to the presentation. Okay, the structure of this session is that the first section is first 15 or 20 minutes. Like I will highlight the practical difference between R, Stata, and Excel, and then introduce a variety of graphs, the type of graphs you might encounter in a research or HTA project. And then the second half, that will take around 30 minutes. Like I'm going to walk through R script and run them together on my laptop and also your laptops. Just for disclaimer, this session is designed for first-time R users, so it might be easy for some people who are very familiar with R. But also like this session is not for like doing data analysis intensively, but for like familiarizing everyone with R and providing simplified templates that you can come back to when you need in the project. Okay, so this is the overview of this session. Okay, let's go to the difference between R, Excel, and Stata. So I think like it's already presented, but R is basically free, and there are a lot of like advantages. It's basically versatile, and also it's a better graphical tools. It provides comprehensive documentation. Also, there is strong community of users and large selection library that allow you to make a lot of tweaks. But the downside of R is a little bit like steeper learning curve. So that's why like we are now like hosting this workshop. Also, like compared to Stata, it tends to be longer in the script. And most of the work will require installation of library that might occupy the storage of your laptop or computers. And also frequently the R and also libraries are being updated, and that might affect running older scripts. And then Excel and Google Spreadsheet. For Excel, like it's free for online, but basically like subscription cost around $100 annually. Like Google Spreadsheet is basically free. The good thing is that it's kind of like intuitive, but downside of it, like it cannot handle like that large data files. Also, it's prone to human errors. It's hard to conduct probabilistic sensitivity analysis. I will explain in next slide. And for Stata, the price tag is a little bit changing, but basically for single users, it costs over $870 for 1 year. When it comes to regulation or other econometrics work, like it's easier to use than R, and then there are more out-of-the-box statistical tools, but cons, limited data visualization capability compared to R. And then Stata can only import one data set at a time, as long as I know. And then, so let me talk about PSA, probabilistic sensitivity analysis. In PSA, like we sample numbers from a distribution to account for data uncertainty. And then like, let's say if you want to like sample 100 numbers from a normal distribution with a mean at 10 and SD at 2, like in R, like you can reproduce the same result by setting a seed, like set.seed function, and then just 3 lines of code, and then you can replicate like those kind of like 100 numbers so many times. But in Excel or Google spreadsheet, like results are kind of unstable, I will show, and then much more steps. And then here, I just recorded a video, like how it will look like if you do the same thing in Excel. Okay, then first I type like function, and then try to create 100 numbers from this distribution. Okay, it's generated. And then I wanted to like label these data, but you can see like whenever you click enter or you do something, unless you fix the number, just like copy and paste as a number, like the result will be changing, and then it's just hard to reproduce the same results. Okay. So then when and what should R be used for? Like I would say like it's good for data analysis and figure creation for one specific project, because R is robust to try different numbers. Like once you finish coding, and then you can do sensitivity analysis involving many lines. And also like when you want to integrate the data with online, like R code can download data directly from some website. Also, you can do scraping. And the lastly, like I think like R is good for geospatial analysis, so that you can import like shapefile, also other figure format. And so these are the difference between R, Excel, and data. Okay. Then let's go to the like our main contents of this session. So here is research cycle. Like I guess like you do data collection and then clean data and analyze data and then visualize data. And then so this cycle, like you will reiterate many times in your project. And then scope of this session is only focused on data visualization, which means that I will not like deeply talk about data collection or data analysis. Just I assume that like you can use the R script. I assume that you already have some kind of like data that already been processed and already been a little bit analyzed, and then you have like the suitable data structure. Okay, then I'm gonna give some overview of figure types and use cases. Okay, so this is a histogram. So it's often used to show like distribution of data and then height of each bar, which is called like a bin, like represent like frequency of occurrence of values within each bin. So this graph shows the how many percentage of people are discharged after how many hours of ICU stay. Let's say like you can see like 7% of people are discharged after 10 hours of staying in ICU. And then the next type of graph is bar graph. So here you can use bar graph to compare data across different groups. Like in this figure shows this is a cumulative death averted globally or sub-Saharan Africa by age groups. Okay, so next one is stacked bar graph. It's a kind of like brother of bar graph. So you can use this one to compare data across subgroups in different groups. And then, for example, so you can show like across a group of strategy, like which subgroup of cost occupies how much of the total cost. So this graph shows by each strategies. This graph shows the total healthcare cost, and then you can see the amount of like each category, like how much it occupies the total cost. And then the next one is scatter plot. So scatter plot explores a relationship between two variables, and then one variable is positioned into one axis, and then the other variable is positioned to the other axis. And then you can visualize trend in data and shape of data. And then, so this is a common use case of a scatter plot in HTA context. So this is cost effectiveness scatter plot. So you can show like how parameter uncertainty impact cost effectiveness. So each dot represents the result of each run in PSA. Yeah, on this graph, like effectiveness is on x-axis and then cost is on y-axis. Okay, the next one is line graph. Like line graph is used to visualize values of variables with gradual change of a continuous variable. It's often time as a x-axis. So this shows like percentage of individuals who have access to antiretroviral drugs in Myanmar. So we will create this graph in later in this session. And then this is a specific use case of line plot. So this is survival curve. This is often used in public health context. Also in your modeling project, you can plot the proportion of people alive over time as a modeling output, and then compare like several interventions, several strategies in your modeling over time. Okay, then this is another common use case of line plot in HTA context. So this is cost effectiveness frontier. So here the graph compares competing strategies cost effectiveness. So line, you can see the dotted line. So line connects successive points like representing cost effective strategies at different value of the cost effectiveness threshold. And then points not on the frontier are not considered cost effective at any threshold. So they are dominated. So for now, like these 1, 2, 3, 4, 5 dots, like under the lines, are dominated. And then how to interpret this cost effectiveness frontier? So that basically like slope between 2 points represent the incremental cost effectiveness ratio. Like I now represent A and B. So in the right graph, so the ICERs are like for A, this line, around 44,000 per query, and then for B, around 130,000 per query. And then depending on the decision maker's preference, the optimal strategy will be different. If they are up for like paying more, and they might like the more higher cost and higher and more effective strategies. And then this is another type of line graph, common in HTA context. So this is cost effectiveness acceptability curve. Like after you conduct PSR, like PSR gives you, like depending on the willingness to pay range, how many times or like how many probabilities like for each strategy would be the most cost effective. Like, and then as willingness to pay threshold is higher, the more effective strategies are more likely to be chosen. Okay, then just for now, like for the next two graphs, like I'm reviewing like what is deterministic sensitivity analysis. Like sensitivity analysis evaluates the effects of input uncertainty on the conclusion. So let's say if you use like these input parameter at these values, you might get some conclusion. Okay, let's say like testing every 3 years is cost effective, then testing every year. But if these inputs values are not certain, these values should have some kind of range for the uncertainty. And then how this conclusion will be different. So we can assess these uncertainty by doing sensitivity analysis for one-way sensitivity analysis. So we will change as just one single parameter value one by one. For example, for one run, I might change like testing, this HIV testing cost to $1, but for another run, testing, I will try testing cost at $10. For the third run, I will try HIV prevalence at 0.1%, and then so in one-way sensitive analysis, like we will vary only one single parameter at one run, but in two-way or like multi-way sensitivity analysis, we will change like two parameter or multiple parameters together. So for example, in first run, I will try like HIV testing cost at $1 and HIV prevalence at 0.1% or for this combination. And then the second run, I might try like another combination, and then so on and so forth. And then so tornado plot is often used in one-way sensitivity analysis to show the effect on a specific modeling output of changing input to the maximum or minimum value in a range. So to interpret this graph, you can see like this mean breastfeeding duration in MCH art have some range. So 8 months as a base case, but 2 months would be like the lowest, like minimum value for this parameter, and then 18 months as a maximum of this parameter. And then the result of models run would change for this range. And then the general rule for this tornado plot is that it's good to arrange the parameters order from most influential at the top and then least influential at the bottom. And then for two-way sensitivity analysis, heat map is often used. Then heat map shows like which decision to choose as a function of two input parameters. And then the color of each cell shows the optimal decision conditioning on the selected value of the two input parameters. And then it typically compares the efficiency and cost of different strategies. For example, in this graph, and also I should note that this cross mark usually means that if this is a base case. So in this graph, this means that the researcher set like 80% of their virogenic circulation and 80% of maternal retention at 12 months as a base case. But if you change like these two parameters together, you can see the color of each cells shows like for each condition, like what would be the most cost-effective strategies. Okay, then last but not least, okay, I'm gonna present the first plot. The first plot is often used to compare result in meta-analysis and systematic reviews. And then this displays like result, often like odds ratio or hazard ratio, and relative risk with the lower and upper bounds of each study to synthesize evidence. Okay, so that's the first part. Okay, let me go to the, okay, let me go to the R. Also, I highly recommend you guys to open R script. Okay. And then let's go over together. Okay, I think these contents are already covered by Islam's presentation, but this is just to get you familiarize the environment. So R Studio have this kind of structure. Then you can open the R script like from a file tab and then open file and then go to the R script in the folder, or like you can also like directly open R script file from some pane. And then in the script, the components are like this, like first load packages and then set the working directory and then read CSV file and then check data components. And then you can run this script by hitting this run button. And also there's some run option, like you can go to the code tab and then you can select some options. Okay, then once you run all the codes, like the result will come up this files or plot pane. Okay, and also like environment pane will have like table of data variables, and in console pane. So console pane displays like commands that have been run or are being run. And then you can directly type and run commands in the console. Okay, the right bottom are files plot pane, and then you can also open figures in the separate window by clicking like zoom tab. Yep. And then so this is just a kind of like refresher of basic operation in R. So pound or hash sign like means that line is just a comment and that doesn't influence functions or operation in R. It's often used to add some comments to clarify what's the intent or purpose of the code nearby. And then this leftward arrow means assigning something on the right side to something on the left. And then the third one, this is function. So when you see something with parentheses. So this is a function. So we call out functions from installed packages, or like you can create function and operate what you want them to do by specifying argument within the parentheses. And then the arguments are specific to each function, so that are like defined by the creator of the package or by you if you make your own function. And then like last one, so this percentage and inequity sign, or like vertical bar and inequity sign. So this is linking operation to connect multiple functions at once. So without this linking operation, we need to assign a result of each function to one object in one line, and then do the next step by assigning a result of one specific calculation to another object. And then so to reduce redundancy, the linking operation can connect multiple functions or that in one operation. Okay, so next, just talking about like frequently used function in the R script. So read CSV function or read underbar Excel function are used to read data from CSV or Microsoft Excel file, and then str or view function are used to check the data structure. And then in this session, so ggplot is specifically very important. It's often used to make plot, like, and then, but just to note that like only ggplot function doesn't work, and then we should know like what column of data should be placed on X and Y axis. Also, we should know like what additional function we need to create. We need to create the type of graph you want to make, and specify additional function with plus sign following ggplot. And then so this plus sign might be might be like confused with the linking operation, this percentage, inequity sign percentage. But when you use ggplot, you need to connect multiple function with plus sign. And then my rule of thumb, whenever you come across unknown functions, just Google. Google is the best teacher. Okay. Oops. Okay, let's get handed dirty. Let's make like this plot, histogram, bar plot, line graph, scatter plot, tornado plot, and heat map. Okay, so let's run the code. For section 0, it's just for install and load packages that require it's run. Then you can run by clicking run button. And now my R Studio is loading the package. Okay, then run this line. So this line is a kind of, how could I say, kind of like magic spell. So it's just, like you can set working directory just based on where this R script is located. It's automatically set a working directory. And then we can import the data. There are 3 CSV files in the folder. Now I am reloading data. And then those data, the first ARB is from World Bank database. It's publicly available. And then this contains like a percentage of people with access to antiretroviral drug from 2001 to 2020 around the world. And then these 2, tornado and heat data, are just the toy data I created. It's just mock-up. for the purpose of the practice. And then for line 29, like we can check the imported data when we use str function. Like, okay, so yeah, you can see so these output, and then compared to CSV file, when you open it in Microsoft Excel or Google spreadsheet, str function shows like first several rows, several data, and the type of the variables by column in a 90-degree flipped way. And then if you use view function, okay, oops, or somehow, I'm not sure why I got error, but okay, let's continue. But okay, if you use view, like hopefully like a new tabs will pop up, and then it shows like more intuitive or like kind of equivalent to how Microsoft Excel or Google spreadsheet shows. Okay, then to make histogram, let's say I assume like we want to visualize the distribution of countries by percentage of females like, who have access to antiretroviral drug in the world in 2020. So first, we want to subset the data, just only focus on female in gender column, and then 2020 in year column in this data. So to subset data, we can run this line, and then we can check the data structure. Okay, now we know that like for gender, like all data are female, and also for year, okay, the all years are 2020. Then, okay, then we can plot using ggplot. So in ggplot function, first we need to specify data. So specify data, and then for histogram, we only need some value, and then genome histogram will automatically calculate the frequency of each percentage. And then if you want to change the color of beam, you can specify color in field argument, and also you can change the color of the border of each beam in color argument, also the number of beam in genome histogram function. Okay, let's run. Okay. Okay, you can see the histogram. Oops. And then one tip to make the graph more kind of like readable or intuitive, easily understandable for readers. So I see that this like decimal point, but I'm showing like number of countries, and the number of countries would never have like decimal points. So in that case, I can set some rule here, just inserting a scale wide continuous function, and then we can set like how many ticks should appear in the plot. Let's run, and then you can see now that the decimal points have gone. Then if you want to save the figures, like you can run ggsave function. Okay. Then let's go to the bar plot. Okay, just assuming we want to visualize the percentage of females who have access to antiretroviral drug in 2020 by country. So now the country serves as a group in bar chart. Then let's use the same data that we used in the histogram, and then we can plot just directly use ggplot function. But now the difference is now we want to use country's name as a group, and then the value, which is like percentage of people as y-axis, and we need to specify the type of the graph we want to show. And then for bar chart, we will use like geom bar function. Just I want to emphasize that when we want to create bar chart, like don't forget stat equal identity argument in geom bar function. So without this argument, the plot will show the counts of the variable of the x-axis. This is how the creator sets the argument.
Satoshi,
Okay. Yes.
I'm gonna have to give you five more minutes. Is that okay? And then
5 minutes.
Yeah, and then I'm gonna ask everyone to just pop in the chat. Would you prefer to go straight into group work after Satoshi's done, or would you prefer to take a 10-minute break? Let us know in the chat. But yeah, Satoshi, 5 more minutes.
Okay. Thank you very much. I think so maybe I think I should talk tornado plot, I guess.
Yeah, I think that's probably the best. Yeah.
Yeah. Okay, let's go to tornado plot. Okay. Tornado plot. Okay. Let me go to the tornado plot called. Okay, so tornado plot, as I said, like often used for one-way sensitivity analysis, and then like you might think that it looks like a bar chart, but it is not the case in terms of like R plotting, and it's actually like putting like rectangles from baseline number, and then so here is the game plan. Okay, so we want to import result data of minimum and maximum and find the difference. It will serve as a side length of each boxes, and then identify the position of each apex of rectangle. So it's kind of a little bit, a lot of steps. So unfortunately, so this is not the data analysis course. So just I assume that you already have some data, and then the needed data is input parameters that varied in your one-way sensitivity analysis as a parameter under parameter label, and then maximum output values by each input parameter, and then minimum output value by each input parameter. And then you should know the output value of your base case run. Okay, then here, just the assumption like we already know the base case value as 1 minus 1.6. And then for this code, So the R calculates the difference between the maximum and the minimum values. And then, if you remember, the tornado plot show the most influential parameter at the top and the least influential parameter at the bottom. So in this lines of code, like R identifies the order of parameters depending on the absolute value of the difference that created in the previous step. And then we can specify the width of boxes. And then here, what R is doing is identifying the position of each apex of each boxes. And then, yeah, then keeping the parameters ordered for this parameter argument, and then identify each apex. Okay, then we can plot these results. And then to put boxes in the graph, we will use geoLect function. Okay. Then we can show this tornado plot. And then here, like geom segment function can put your baseline as a vertical line. Okay, so this is basically the tornado plot. So sorry about like not fully cover all the contents, but I think it's a time, right? Josh?
Yeah, so I think, okay, so what we can do now is if you don't have any questions, feel free to take a 15-minute break. And then Satoshi, if you can just hang on the line for any questions that people might have. So we're not going to actually break out into breakout sessions. What we're going to do is we're going to troubleshoot any coding problems you might have. And then hopefully we can sort it out. And if you don't have a question, then we'll meet back on the hour. And you can feel free to take a break in that time. But yeah, if you have any questions, shoot now. We'll try to do it in order. I think the first question is Sayem Ahmed. He said he got an error when running the tornado. So error in Vita, could not find function view. Okay, Sayem Ahmed, change your view function to a capital V at the start. So instead of a lowercase view, change it to yeah, it should be that, I think. Satoshi, do you know?
Yes, I have the same issue, probably because some kind of update.
Could be that, yeah.
Yeah.
Otherwise, what you could do, so I assume that's calling the saved tornado plot, right? So what you could do is you could just, as Satoshi's done, is you run the code. You don't save it directly using code, but you open it up in your plot panel, and there should be a function there to save it directly, and then you can view it as a file. But I think Delish might be right as well.
I tried the capital V and it shows me the data set for this plot. Yeah.
Okay, yes, yeah. That's yeah. So that's not the right function. So yeah, it is a lowercase v.
Yeah.
But Sam, does it, when you run the code, does it open up in your plot panel?
No, it does not open in plot panel. It opened the data set, I think.
Oh,
tornado
Satoshi,
plot
yeah.
data set.
That's how it's supposed to do.
Okay.
Okay.
Perfect.
So,
Yeah, when you're viewing, you're doing it in the data set. So it usually comes just next to the source panel.
And then Sayam.
Oh, I can see the I can see the plot now in the plot panel. Yeah, thank you.
okay.
Perfect.
Okay,
Yeah.
great.
Perfect. Okay, if there are any other questions, we'll be here. Otherwise, 15-minute break, and we'll reconvene on the hour in exactly 12 or 13 minutes.
I think maybe let's give it a minute. Can everybody see my screen? Okay, thank you for listening. Okay, so my name is Bohle Ndweni. I'm a health economist, and I am currently a lecturer at the University of Cape Town in South Africa. Teaching the postgraduate studies there in health economics specifically. And I am one of the co-chairs of the R-HTA and LMICs Chapter. Apologies for only joining now. I had teaching obligations beforehand earlier on. So today, what I am going to walk you through is just the modeling basics of decision trees. I think I don't want to assume that everybody knows what they are and so forth and how they work. So what I will do is just go back to basics. For those that are advanced that know these things, I apologize, but please bear with us. And then later on, we will look at a very simple decision tree that has been coded in R. And then we will have group work where you can tweak around some of the things in that model. So everything is actually in the repository. Josh, I hope it is. I haven't checked, sorry about that, but the R script should be in our GitHub repository for this workshop. Okay, welcome everyone. And I know I'm taking the last leg of this and you're probably tired, but please bear with me. So just as a background, I think when we think about decision trees, we do think about the standard Gamble theory, where it would then, it would measure the disutility of health states by observing the willingness to accept a certain risk of death in order to avoid a state. So typically you would have, in this framework, you would have a respondent that would be asked to consider two alternatives, right? One would be the gamble, which would be characterized as, okay, there's this risky treatment that you can go on. If maybe you have a certain illness, but then there is a risky treatment, which two possible outcomes would you consider? Would it be life in a state of perfect health, where it would have a probability P, or would a person opt for immediate death, which would be probability 1 minus probability P? And then the other alternative would be either for the person to just live with the health problem that they have, and with the certainty that they'll just live with it for the remainder of their lives, and that's the way it is. So basically, that's the concept that we think about when we think about decision trees. It's are you going to take the gamble or use one option over another? And then it talks here about the measurement objective of this theory being to identify the probability of perfect health, where the respondent would then be indifferent between either alternative that's given to them. So meaning the point at which the two alternatives seem equally attractive. So once this indifference point has been identified, a health state valuation for that particular health problem of interest will then be equal to P. And the logic of this inference derives from the setting that the utility of perfect health is 1, and that the utility of death is 0. And obviously this is not the way, if you've seen decision trees before, there obviously will be other alternatives in here, right? Where maybe someone is in a certain state, but you will see that those values would be less than 1. So they definitely would be in between 1 and as maybe let's say you're measuring someone's pain threshold, right? And maybe at this point here, they may be in pain, but not it's moderate pain or very light pain. But so the number would be closer to 1. But if maybe they're here, meaning they're closer, they've got severe pain, so maybe they could value that as being closer to death, really, but not really close to death, because we know that, I mean, not really death, because we know that death is equal to 0. So that would assume that at that point of indifference, that respondent considers the expected utility of alternative A and alternative B to be the same. So this just shows you what it looks like in mathematical format. And that's just a simplified version of it. I mean, obviously, if you multiplied 0 by that, you would get 0, right? So it would then give you P equals U for the health outcome. Okay. Again, like I said, this is more theory. So decision trees are just quite simple. They're a very simplified mode of a model, really. In the next session, everybody who's presenting there will go into your more complex models that look at a longer time horizon, but oftentimes with decision trees, you would have, for example, shorter time spans. Like, for instance, in research work that I'm doing right now, I'm just looking at something with time horizon for 6 months, for instance, for the decision tree. And then you would also need to consider which perspective are you taking here. Is it going to be a provider perspective? Is it going to be a societal perspective, and those kind of things? But obviously, so I'm just trying to help you see that there's a continuation in how you do these. So whatever it is that you're going to consider in your model for your decision tree, you also, if you're going to now plug it in and go forward with the time horizons for your, let's say, for instance, a Markov model, these are things that you would need to give consideration into. So just to talk about the pathways. So there would be different pathways, right? So these are routes through your decision tree. And they are a sequence that is mutually exclusive to each other. So, for instance, okay, I'll talk I'll talk about this when I'm talking about the decision nodes. But basically, you would have your probabilities that would show the likelihood of a particular event occurring. For instance, at a chance node. So maybe just to make sense to you, so you would begin maybe with a condition here. I'm trying to think. Yeah, whatever disease it might be. Let's say maybe it's HIV, and you're thinking of what treatment that someone would be on. So you would think about, okay, what would happen if someone goes to alternative A or goes to alternative B? So your square decision node would then show the point between the two different alternative treatments in this case that you would look at. And then your chance nodes, these would be those branches that would come out of that would come out from here, right? And they would show you a point where these alternative events, they would show you the patient pathway for the alternative events that the patient would go through. For instance, it would either be, if for alternative A, using the standard gamble theory, for example, you would have the patient go to probability P, and then the other alternative would be going to probability P minus 1, that is for death. The terminal node just basically gives you it contains the records that it does not pass through to any further decisions. So this is where it stops. And so you would need to measure whatever costs or expected values and so forth for whatever pathway it is that you would have chosen or that you choose to measure in that instance. So I think I've just summarized this, that you would move from left to right in terms of how you read your decision tree. And the pathway, the joint probabilities for the pathway would be obtained from multiplying the probabilities that are along that patient pathway, for example. Okay, so I mean, this is a lot of just theory, but if you have the green book, so when we talk about decision modeling, we have the green book that we refer to. So this is from the Briggs book, which is about decision modeling. And this was, yeah, just one of the things that is there. I'll explain this a bit later as to how they got to some of the numbers. But this is just explaining the theory to you. I'll share these notes, the presentation slides with you, where you just understand what the joint probability is, conditional probability, independence, and so forth. In the interest of time, I'm just going to move on. So coming back to the pathways that we spoke about. So this is a very simplified format of it. So that would be one pathway. We talk about pathway A, that would be pathway B, and so forth. So if we're talking about that, we think about the expected values that we would have using the cost. So this would be if you're given an option, the likelihood of each prognosis can be quantified using probabilities and their cost implications for whatever health outcomes that there would be. And the payoffs, sometimes when we talk about payoffs, it would maybe be the health outcomes that would come from that. So cost would typically be one of the payoffs that you would think about. And then most of you would have heard about quality adjusted life years, which is something that is used a lot in high income countries. But if you're in low middle income countries, we sometimes maybe would use something that is different, which would be maybe disability adjusted years or life years or whatever it is, depending on what model you're using. It could either be deaths averted, disability adjusted life years averted, and so forth. That would be for your cost effectiveness analysis. And so basically this just shows you what you would have if, for instance, you have, it's a calculation for the expected cost. So you would maybe have a cost of, let's say it's £100 for lack of, yeah, let's use pounds maybe. And then your probability is 0.1. So you then would multiply those two, and then from the different pathways, you would add that, and that would give you your expected costs. And these are just the calculations that would explain some of the numbers that you're looking at here, just so that they make sense. Like I had mentioned in the previous slide, you would have the numbers that go together. So you would multiply that to get the probability, that is that 0.331 that you would have there, and so forth and so forth. And then when you add everything together, then you would see that your probabilities, if you want to do your checks and balances, do actually equal to 1. And then for the expected values, you would then multiply the probabilities. Let's say I made an example here using pathway B. You would have the probability for pathway B and that for cost, and then multiply that. And you would be able to get the expected value. Actually, I got a different number from the book, but that's the number that I got. It was 7.33. And then for expected utility, it would be probability multiplied by utility. I used pathway C here. And yeah, this would be the number that I got. So it was a negative value there, which from my understanding, it would be a number that is, if someone thinks that the situation is worse than death. And then some of the numbers, either you would get a table of parameters or variables that are given to you sometimes, or if not, then you would have to consult literature in order to be able to get those utilities. Okay, so before we do the exercise, I'm just going to share my screen so that we can look at, I'm going to stop sharing for now, so that we can just quickly look at disability that I have in store for you guys. Okay. There you go. Please let me know if you can see my screen. I can't see, sorry, I can't see things because I am sharing my screen. So if you can give me a thumbs up, cool. Thank you so much. So again, I reiterate that this is a very simplified model for using a decision tree. Usually decision trees are done in Excel. That's definitely how I learned it when I was doing my master's. And some people think it's not even worth it to go and do it in R. But sometimes if you want to do everything in R and just keep your stuff there and maybe collaborate with other people and see if you can work around complexities, it maybe could be, it's a nice thing, maybe a nice to have, but it would be nice to actually look at it. So the packages that I'm working with here are R-plot and R-plot.plot. So you can just install these. And then once these are installed, you just have to recall them, but just, putting them there so that you can run your plot. And then in this case, I did not have data. So I am using simulated data, but you're welcome if you have maybe original data or aggregated data to maybe play around with that and see if, how it works around. So basically I just simulated data and then I just wanted my, to have a sample of 200. And that's what I plugged in there. And you will see here, this is my table with all the various elements. But before I even go there, I'm just here. The main purpose is to just show you, it goes up to 200 samples, right? Or the number of people that we're looking at here. And so in order to make it neater, you just decide that, okay, you name it. I think Islam spoke to the naming conventions and syntaxes and all of that. So I'm not going to go into detail on that, but basically it's just simulating your data and then putting it in a table that is going to be neat for you. And that's how it looks the way it looks. There. It's R-HTA automatically did it for me once I had, these were put in. And then here, these are just the age groups around here, the sample sizes that I were using. So just to clarify, sorry, this is a decision model, tree model for breast cancer. So it's not my area of expertise. But I just decided to do that because it's something that maybe some people could identify with. Cancer is something that, yes, Sayem, the script is available on GitHub. If you can access it now, I think if you can open it because you probably are going to need it to do your exercises. Okay. So what happens after that is then we then would look at, I didn't do all the variables. So the ones that I actually wanted to look at were some of the like the ER status. So that would be your estrogen receptors, right, that are used in breast cancer. So another good thing that you need to do when you model, which I think either Satoshi or Islam spoke about, is to always make notes, right? Because you might not use a script for X amount of weeks or months, and then when you go back, you can't remember what's what. So it's nice to just make a note of what you did there or what stands for, and then you know what to do. But basically, I'm just calling into my data and I'm saying, so I'm just saying I would like to look at stage 1 and 2 here, and if it's positive for that estrogen receptor, then the patients would have to go for hormonal therapy. And if not, then if they have stage 3, then they can go for chemo or radiation therapy. And then you obviously, like in any other model, there's always going to be patients that would die. In this instance, maybe there's patients that there's nothing that can be done medically for them, and so they would be placed on palliative care. And then you just call that from your data frame, and you then would fit the model. So that's where your R-HTA function then comes into. And then you can you can put in the various, these are the various columns that you had in your, so these are the various columns that we had in the table, and you're just calling them there, and you want to classify that. And after that, you just want to plot your tree, and just to make it neat, right? You can put in a certain way. It's things I want you to look at when we do the exercises. You know, what happens when you play around, fiddle around with some of the code and how it looks like. So I ran this earlier, and this is what I got. So basically, that is what I was saying earlier on. So you have the different alternatives. So if a patient has got stage 1, 2, and 4, then they would go to either being ER status positive, then the ones in stage 1 and 2 would get that hormonal therapy, and then the ones that were ER positive, that were in stage 4, would then go to palliative care. And then in this instance, you then would have a group of patients that went straight into palliative care. And then for here, those that were in stage 3 could go still in chemo therapy. So yeah, so I finished just a bit earlier. I don't know if there's questions for now, or we can go. Oh, sorry, before I go there. So this is just, just some predictions perhaps if you want to look at the table in terms of you want it to appear in table format like it is appearing here. So I was just playing around with some numbers there, so just ignore that. But yeah, that is code for that. But obviously, there's no one way. I think the thing here is there's no one way of doing something. We all do things differently. So the way that you code might be different from the way that I have done this, but the main point is if you can explain why you did what you did, and how, and justify it, and it's, I guess, reproducible for somebody else to be able to do it as well. So I don't know if there's no questions, I'm just going to let people go into the groups. Is that okay? I feel like I'm talking to myself. Sorry, nobody's saying anything.
Hi, Abraham.
Hi, Satoshi.
Yeah.
Can
This
we
is
go to
great.
the group? Yeah.
Yeah, people are asking where is the R script available in GitHub? Like, if
Yes,
it's available,
it is available. Josh, is Josh still here? So I had asked Josh if he could load it on GitHub. Okay. Okay, Nicodemus. Okay, must unmute you, sorry. Like, yes, you can unmute yourself. Sorry, yeah,
Yes.
there we go.
Thank you. Yeah, my question is for this decision tree, is it done differently in cases where you have to make a decision based on the costs and effects? Because I don't know if this was incorporated in the decision tree that you made. It looks like it's from effectiveness, or I don't know.
Yeah, so for this particular one, it's just effectiveness. So it doesn't include the cost. So yeah, no, unfortunately, this one doesn't include it doesn't include the cost as well. But I believe, Josh, you must correct me if I'm wrong. I believe Josh in day 2 is going to go into the Markov model, but I think one of the things we had discussed was that he would look at how to incorporate a decision tree into the Markov model. So obviously there would be costs and all of that, but I don't think he will be using whichever data he's using or whichever model he's using.
Okay, thank you. Just wanted to to know.
Yeah. No, this one doesn't have costs. There's no costs at all. Like I said, it was just simulated data. Yeah, unfortunately, with things that are happening in the global sphere, we tried to get data from somewhere, and unfortunately, I'm in South Africa, so we were blocked from accessing certain data that we had thought that maybe we would use that to simulate certain things. So unfortunately, I just had to simulate this. Okay, Sayam, you can unmute yourself, please.
Yeah, just add to this, maybe in the decision tree, we deal cost and effectiveness similarly. So if we have the probability of different terms, then just because cost and effectiveness, those came as a payoff. So we use those probabilities to multiply with the cost similarly to the effectiveness. So yeah.
That's true. It's not done in this model. Sorry, I know I showed you that from the theoretical perspective, but it's not incorporated in this model. Is that what you're asking? Sayam?
Yeah. I understand. Yeah, cost is not assigned here.
Yeah.
But I was just trying to say that that can be done easily if the information is available using this similar approach or similar code.
Yeah.
Yeah.
Thank you.
Yeah. Thank you.
Thanks.
Thank you. Yeah.
Okay, you're welcome. So, these are some of the questions that I have. So, if you can, can somebody confirm? Have you gone into the GitHub, and were you able to see the script or not? Can somebody confirm, please?
I cannot still see the code in GitHub.
Is it so you
Only,
can't
yeah.
see something called R decision tree oncology, R script and exercise?
Yeah.
Oh,
Yeah, unfortunately, not for my side.
there's nothing there. Okay. I'm trying to see how I can share the script in here. Okay, it's fine. Maybe let me just, is it okay if I do it here or, yeah. Let me just, I don't know, guys. I don't know how we're gonna sort this out. I'm trying to see if I can add it here. Okay, let's do this. I have everybody's email, right? So what I'll do maybe is let me attach it in an email and send it to people for now. Is that fine? Hello?
That works for me. Yeah.
Okay, so I will just attach the R script in there. And then in the meantime, I'm just gonna put you guys into your groups. These are to make it easier for you. So these are the things, the exercise questions. Just play around. That's what I want you to do. Play around, and then I'd like to see what you see in your plots. You know, what does it look like, and what is included there, and so forth when you change the different things. Okay, so I'm just gonna open the rooms, and then I'll quickly email everybody or get Josh to put it in the GitHub. Okay.
Okay.
Thank you. Hi.
Okay. Yeah, some people suggest, like, why don't you like copy and paste your script on the chat on Teams if it's allowed?
And then they would be able to copy and paste it in R.
Yeah, the R script on each.
Okay.
Yeah, each
Okay.
laptop.
Let's hope it works, guys. That's what I'm
Yeah.
gonna do. Let's hope it works. Because that's what I was trying to do. I don't know where I'm supposed to click. That's the thing. Let's see. Because I'm in the chat, but I don't have anything to attach it. Okay, wait, let's see.
Yeah.
Wait.
Yeah, I think so. On my end, also, like, I cannot like upload the file directly.
Okay, so it says code snippet. So that's what I'm gonna do then. Hopefully this works. Okay. Okay, let's see if I do that. Okay. Let's say exercise. Okay. Insert. Okay, it's in there. Can everybody see it? I think it's just a snippet. It says expand. Let's see. Yeah, it's in the chat now. So if maybe you can copy and paste it into your R script, but then I will open the breakout rooms for the next 15 minutes, 5 minutes. Is that okay?
Okay.
We
Hi.
cannot see it in the chat yet. Yeah.
Really? I
Yeah.
can see it. How come people can't see it? Okay. Islam, you were saying?
Not yet in the chat. I cannot see it in the chat. Yeah.
Okay. Okay.
Then
There we go.
let's
Wait,
stick to
sorry, my
email.
bad. There we go. There we go.
Oh,
Oh, it is coming now.
oh, yeah.
Sorry. There we go. Okay, cool. So I'm opening the chat rooms, and then I will keep popping into some of them. Okay, to see what you guys have. And then if you want to, maybe whatever plots you have or whatever change, maybe just share it in the group as well in your individual breakout room chats. Yeah. See you in a bit.